Hi everyone. The section we're looking at today is called connected rates of change. And essentially connected rates of change is when we have a rate of change which involves different variables. So different variables. I'm just going to write this down for you. So for example, I might have the volume and the area. And I look at how these two variables change over time or with respect to time. So the change of volume, change of area with respect to time. And it's essentially a rate of change is the change of something with respect to time itself. So that word rate refers to a change over a period of time. We've kind of come across this before when we looked at differentiation and we looked at using the chain rule. Now, if you recall, the chain rule we could write as dy by du times by du by dx. And that allowed us to relate y to x by with this third variable u in there. Okay, so let's have a look at these first three examples there just to illustrate and think about what this word rate of change means when I think about particular variables. So I see here that a container fills at a rate of 15 centimeters cubed per second. Now, centimeters cubed refers to volume, and this rate refers to time. So I can rewrite this sentence as dv dt is equal to 15. And that states there that the volume changes over time at a rate of 15 cubic centimeters per second. And so that is a rate of change there. Second example says the radius of a circle changes at a rate of 3 centimeters per minute. So the radius changes over time. And I can write that as dr by dt, the change of the radius over time, is equal to 3 centimeters per minute. Sorry. In the third example, it says an area of grass grows at a rate of 2 millimeters squared. There's another clue that I'm working with area per day. So area is what's changing over time. So I can write this as dA dt equals to 2. So in all of the problems we're going to come across, we will have to set up this rate of change equation. And remember, the topic is connected rates of change. So in general, I'll have a connection between two things, like the volume and the area, or how does the area change as the radius changes, etc. Okay, so let's have a look at some questions here. And it starts out simple, and then by question 4 and 5, I get onto some past paper questions. Okay. So I've set up here a few steps to just help us keep track of what we need to do. So first, let's read this problem. Given that the volume is equal to 1/3 pi r cubed and that dv dt is equal to 8, so that means dv dt is how the volume changes over time. And this is my formula for volume here. I want to find dr dt, the rate of change of the radius, given that the radius is equal to 3. Now, if we were to try and visualize this problem, then let's say I had some 3D shape where I have a cross section that's a radius. And as my radius is equal to 3, and let's say I'm blowing air into this shape, let's say it's a type of a spherical balloon. if I am blowing air into this balloon, then I want to find how the radius changes over time, dr dt. At that instant in time when the radius is 3. And I'm told that the rate of change of the volume is 8. So if you can just try and visualize that might help a little bit. But let's just see how we go about this systematically. I'm going to set up a chain rule equation. And what that means is I generally will always start with what I want. This is what I want. This is what I'm given. And this is my formula, which I will differentiate. And in this case, the connection is V to R. So I know from this I'm going to find dV dr. And I'm also given this bit of information which I will have to sub in to get to the final answer, to work out the final sort of rate of change. At this point here, I'll have to sub in 3. So I'm going to go through this slowly. Whoops. First thing I want to do is set up a chain rule equation. So connected rates of change equation. So I'm going to start with what I want. I want dr dt. Okay. I am given dv dt. So I know that this dr dt must be equal some rate of change multiplied by another rate of change. And what's going to happen is I'm going to always use what I'm given. And what I'm given here, dv dt, must multiply in such a way that when I cancel these two fractions, I end up with dt at the bottom and dr at the top. So if we think about this, I don't want dv, I want dt at the bottom. So I need to multiply by something here so that it will cancel the dv, which means I need a dv at the bottom here. And I need dr at the top because, look, I'm trying to find dr dt. It's a bit like saying I want 3/4 and I have, let's say, 7/4. What must I multiply by? What must I multiply 7/4 by in order to be left with 3/4? Well, it makes sense to say here that I'll need a 3 at the top and I'll need to cancel the 7s there. And then I'm left with 3/4. So I'm approaching this in the same way. So let's just do this again. I want dr dt and I have dv dt, which means I need to keep the dt at the bottom, but I want to get rid of the dv. So I need a dv here at the bottom, and then I still need I need this dr. So I put dr there. And then I look and I notice, well, yes, I'm given this. I know that this is 8. And this dr dv is really good because from my formula, I can find dv dr. I'm given that v is equal to 1/3 pi r cubed, and I can differentiate the volume with respect to the radius in order to find dv dr. And dv dr, well, I'm differentiating the radius cubed. So remember, I times by the power and decrease the power. So it becomes 3 times by 1/3, which is just 1, pi r squared. Now, dv dr is pi r squared. And I want dr dv. Right, so I can say, therefore, dr by dv must be 1/. I take the reciprocal. Hope that makes sense. I'm going to now, I've set up my chain rule equation. I'm going to, I've kind of done step 2 and step 3 as well. I've subbed in my given rate of change, which was dv dt. I've done that. I find my missing rate of change from the formula given in the question. And the formula given in the question was V equals 1/3 pi r cubed. So I've done that. And then I'm going to work out the rate of change I've been asked for. So I can now rewrite this equation. dr dt is equal to dv dt, which we know is 8 from the question. And we've just worked out that dr dv is 1 over pi r squared. And the final part is I want to work out the rate of change asked for this condition, r is equal to 3. So when r equals 3, I get that dv dt is equal to 8 times 1 over 9 pi, because r is equal to 3, so r squared is 9. And that simplifies to 8 over 9 pi. And there we go. That is the first problem we've looked at. And it does get a bit easier. It just takes some time to get your head around this. Okay, let's look at example 2. We're given that the area is equal to 1/4 pi r squared, and that dr dt is equal to 6. So I'm given a rate of change. The radius changes over time with a rate of change of 6. I want to find dA dt when the radius is equal to 2. Okay, so I'm going to set up my equation. That's step 1. Let's go back to have a look. Set up the chain rule equation. So I always start with what I want. I want dA dt. I'm given dr dt. So that becomes my next bit. dr dt multiplied by, well, as I can see, I want to cancel the dr here. I can also at this point in time compare it to my formula a equals 1/4 pi r squared, and I know I can differentiate this to get dA dr. That gives me 2 times 1/4, which is 1/2 pi r. Okay, so going back to this equation, I want dA dt, and I want to cancel this dr here. So I need a fraction with dr at the bottom, and I need dA at the top. So it's going to become dA over dr, because now the dr and the dr cancels, and I'm left with dA over dt. Okay, so there we go. We can now sub in my values. I know that dr dt is 6. I've got that in the question there. And I've just worked out that dA dr is 1/2 pi r. Then I know my final bit is to work out my answer when r is equal to 2. I know that dA dt is going to equal 6 times 1/2 times pi times 2. 2 times 1/2 is 1, so I'm left with 6 pi as my final answer. Okay. On to example 3. This is actually an old exam question. The radius of a circular pool, that's important, circular pool, so we know that that circle means that the area of a circle pi r squared. I'm going to use that. The radius of a circular pool of oil is increasing at a constant rate of 0.5 centimeters per second. So I can write that down, dr dt, because remember my keyword is rate. That is over time. That's where I have the fraction over dt. dr dt is equal to 0.5. They want me to find in centimeters squared per second, so that implies area, to 3 significant figures, the rate at which the area of the pool is increasing, when the radius of the pool is 200. So there we go, the area of the pool. I want to find the rate at which that is changing. So I want dA dt. Now remember, I wrote down on the side here that the area of a circle is pi r squared. Okay, so if I have that the area is pi r squared, I know that I can work out dA dr, which is 2 pi r. And I'm going to connect all of this together. I always start with what I want, which is dA by dt. dA by dt is equal to what I'm given, dr by dt, times by whatever I need to write down to cancel, so that I'm left with dA at the top. I want dA at the top, which means, and dt at the bottom, which means that needs to be a dA dr. And look at that, we have found that already. That will always be the connection in the question to the formula of whatever shape you are working with or you're given. Now I can fill in the rest of the information. I know that dr dt is 0.5 and dA dr is 2 pi r. And remember, my final bit, I want to sub in the value at which I'm trying to find this rate of change. So when r is equal to 200, I know that dA dt is going to equal 0.5 times 2 times pi times 200. Now half times 2 is 1, so I just end up with 200 pi. I must go back to the question. It specifies that I want this to 3 significant figures. So I need to go and work that out. 3 significant figures. When I type that in, I get 628 centimeters squared per second to 3 SF. There we go. Okay. Question 4. This is another old exam question. The volume of a right circular cone. A right circular cone is increasing at a constant rate of 27 cubic centimeters per second. The volume is increasing at a constant rate. So dV dt is equal to 27. That will give you 1 mark if you just write out your initial rate of change. The radius of the base of the cone is always 1.5 times the height of the cone. So this question has a little bit more detail to it. The radius of the base of the cone is 1.5 times the height of the cone. Okay. Calculate the rate of change of the height of the cone. So what we want dH dt, the rate of change of height, when the height is 4. Okay, so I'm just going to try and visualize this cone that they're talking about here. Hang on, the base is actually, it's got to be a bit bigger. And there's my cone. Right, there's my radius. And when they say right cone, they mean that you have this, you can draw in this 90 degrees triangle from the top of the cone to the base, the circular part at the bottom of the cone. So they tell me the radius of the base of the cone is 1.5 times the height. Now this isn't drawn to scale, but let's call the height x. Then the radius needs to be 1.5x. Or actually, if I just keep the height as h, well then I know that the radius must be 1.5h, 1.5 times the height. Okay, the other thing you need to recall is that the volume of a cone, is 1/3 pi r squared h. So it's 1/3 of the volume of a cylinder. So if I fill in the information that I have here, so that I eliminate my radius, so I have an equation just in terms of h, then I will get 1/3 pi times 1.5 h squared times h. And I'm going to simplify that, and that is going to give me, well, that's 1/3 pi, that's 3/2h all squared times h, which gives me 1/3 pi times 9/4h squared times h. You can, of course, use your calculator. That gives me 9/12. 9/12 pi h cubed. 9/12 pi h cubed, which is 3/4 pi h cubed. Okay, and that is the volume of a cone. You could use your calculator and just simplify that quicker. But there you go. Okay, so that is the volume of the cone, and we are going to find dh dt when h is 4. But I need to set up my equation. I start with what I want. I want dh dt. I write down what I have, dv dt, and then I fill in the missing bit. Well, I need to cancel the dv by the bottom, and at the top I need the dh. Okay, and again this bit is going to link to this formula here. When I differentiate v with respect to h, I'm going to get that from v equaling 3/4 pi h cubed, dv dh is, well, that's 3 times 3/4, which is 9/4 pi h squared. So I can fill all of this in here. dv dt I'm given as 27. I've just worked out that dh dv, well, I've worked out that dv dh is that. Now I want dh dv, right? So I want the reciprocal. At this point, it's probably easier to go and sub in h is equal to 4. Because then when you take the reciprocal, you don't have to fuss with the 9/4. It doesn't matter, but we can do this here. dv dh is equal to 9/4 times by pi times by 16, and that's going to give me 36 pi. Therefore, dh dv is 1/36 pi. I take the reciprocal. And I then go and plug this in here. 1/36 pi. And I simplify, so I get 27/36 pi, which both of those are divisible by 9. So that gives me 3/4 pi. And the question did say to 3 significant figures. So if I work that out, I get 0.239, and that will be centimeters per second to 3 SF. Okay, so this question would probably have been about 6 or 7 marks because there is a bit more working out required. Okay, final question we're going to have a look at, another past exam question. They tell us that figure 2 shows a right circular cylindrical metal rod which is expanding as it is heated. After t seconds, the radius of the rod is x and the length is 5x. The cross-sectional area is increasing at a constant rate. Okay, the cross-section area is this, and that's pi r squared, the cross-section area. and it's increasing at a constant rate of 0.032. So straight away we can say, well, the area dA dt is going to equal 0.032, the rate of change of the area. I'm also given that the cross-sectional area, or I'm not given it, but I know it's a circle, so I can write this down. A is equal to pi r squared, and then at some point I know I'm going to work with dA by dr, which is 2 pi r. So they're asking me in part A to find dx dt when the radius of the rod is 2 centimeters, giving my answer to 3SF. So what I'm going to do is, as I said up there, well, I must also remember, now that I look at this again, the radius is x. So let's go and write this out. Area equals pi x squared, because the radius is x. In that case, I am going to work out dA dx, right, which is 2 pi x. Would have been the same if I just, in this case, went and replaced r with x. I would have got dA by dx is equal to 2 pi x. Okay, they're asking me to find, this is what I want, dx dt. I'm given dA dt, and I need to multiply by the fraction, which will cancel in such a way that I'm left with dx dt, and that's going to be dx over dA. So I know that dA dx is 2 pi x, therefore dx dA is 1 over 2 pi x. So I can fill in everything I have here, 0.032 times by 1 over 2 pi x. And I go back to my question. I know when the radius is 2, so when x is equal to 2 is when I want to find my rate of change, dx dt. So I end up with 0.032, all divided by 2, times pi times 2. And that cancels down to 0.00255 to 3SF. Okay. In part B, we were asked to find the rate of increase of the volume of the rod. The volume of the rod. Now remember, the rod, when we look at it, is a cylinder. I want to find dV dt. This is what I want. Hopefully you can recall that the volume of a cylinder is pi r squared h. And we know that r is equal to x and h is equal to 5x. So we can rewrite the volume in terms of x only. That's going to be pi x squared times 5x, which gives me 5 pi x cubed. So I want to find dV dt. I'm given the volume in terms of x, so I know I'm going to have to find dV dx. dV dx is 3 times 5, 15 pi x squared. And if I go back here to what I'm trying to find, dV dt, I can say, okay, I have dV dx. I'm going to have to multiply by dx dt, because that will cancel and leave me with dV dt. So dV dx is 15 pi x squared multiplied by dx dt, which I just worked out in part A, which is 0.00255. I also recall that I want this when x is equal to 2. So dV dt is going to become 15 pi times 2 squared times 0.00255. Plug that in to your calculator, simplify it, and you should end up with 0.480 cubic centimeters per second to 3 significant figures. Okay, so lots to take in here. It is a little bit like a puzzle. That's what I always think about. You know that you want a chain rule equation. You start with what you are given, because you're going to sub in the given rates of change from the equation. You find the missing rates of change, so what you don't have. And this will always come from the formula that you are given in the question. Volume of the cylinder, area of the circle, etc. And then you work out the rate of change that you are asked for at the given point value in the question. Hope that's useful. And if you have any questions, please let me know.